So the first thing you want to do is you want to open the do file for diabetes on Blackboard. So there should be a Stata do file, diabetes.do. So just click the link to diabetes.do, and then if you have Stata installed, then it should open that do file in Stata and give you all the code there, right? And then you could just highlight all the code and then run the code. I'm just going to press the play button on that first line of code. So see use diabetes.dta. So diabetes.dta is the data set for this week. And then you could browse the data set here and see it has how long you've had diabetes for. Did you have it never? No diabetes? Did you have it for less than 10 years? Or did you have it for greater or equal to 10 years? What type of diabetes did you have? Did you not have diabetes? Type is none. Or did you have type 1 diabetes where you can't produce insulin at all? Or did you have type 2 diabetes where you can produce insulin but you're not able to regulate insulin effectively? Do you have the bacteria or not? So bacteria is some type of infection. In the book, it's some type of bacteria. I mean, we could just think of it as COVID, right? So there's this big discussion in the readings for the courses whether or not diabetes sort of causing COVID or correlated with COVID. So bacteria is equal to 1 if you have COVID or if you have bacteria. Bacteria is equal to 0 if you don't have bacteria, you don't have COVID. Diabetes is equal to 1 if you have diabetes. Diabetes is equal to 0 if you don't have diabetes. So tab is just, again, to show the table. We did some of these earlier in the semester where the p-value is, that's the chi-square test, so PR equals 0.000. PR, we say it's less than 0.001, right? And we would say that's a statistically significant difference, really small p-value, so you would not get that table by chance, right? The p-value is a probability, so the probability is really low. You're probably not going to find that result, meaning just by accident or by chance. So it means there's some systematic pattern in the data. Here you would say that maybe diabetes and bacteria are correlated, or maybe diabetes has some type of influence on bacteria, that people with diabetes are more likely to have COVID, more likely to have bacteria, or people with bacteria are more likely to have diabetes. Either way, right? So that PR, that probability, that's the p-value. If it's really low, it means it's statistically significant. Statistically significant meaning that there's like a statistically meaningful difference in the data that the data is detecting. If the p-value is really high, it means it's not significant. If the p-value is really high, it means whatever differences you're finding could just be by chance and could just be by the sample, that it's not a big enough difference to sort of measure it statistically. So again, the p-values are all really low. That's saying, yes, these are differences. So if you've had diabetes longer, rates of the bacteria infection are higher, rates of COVID are higher. Again, it's labeled bacteria. You could think of it as COVID or some type of health risk, some type of health condition that might be related to how long you've had diabetes. So less than 10 years, more than 10 years, none. And then if you run it on type of diabetes and bacteria, again, remember type 1, you cannot produce insulin at all. Type 2, you can't really effectively regulate the insulin that you are producing, right? So they say that type 1 is like, you don't have a key to regulate your blood sugar. Remember, diabetes is sort of excess blood sugar, and insulin sort of regulates that. Type 2, you have a key, so you could produce insulin and regulate your blood sugar, but the key is sort of broken, that you can't monitor your sort of blood glucose, blood sugar. Now, if you do logistic regression, these are what they're doing in the book chapter, and I have the exact same data from the book chapter, is that you can see the different odds ratios here, right? And how you read the odds ratio, if it's the odds ratio is greater than 1, it means it's larger. So, right, this would be that, okay, well, bacteria is higher among people with diabetes, that the odds of bacteria for people with diabetes are 3.54 times higher than for people without diabetes. So if you have diabetes, you're 3.5 times as likely to have the bacteria. So the odds ratio on diabetes is 3.54, so that means you're 3.54 times as likely to have bacteria if you're a diabetic than as if you're not a diabetic. Right, so that the higher the rate of diabetes, higher the rate of bacteria. The odds ratio is greater than 1. Again, that p-value 0.000 on diabetes, that means it's statistically significant. Right, that odds ratio is statistically significantly different from 1. So we're ruling out that the association goes in the other direction, and we're ruling out that There's no association. Again, you can see the p-values here, so these are statistically significant detections of association. So if you've had diabetes for less than 10 years, you're 2.98 times more likely to have the bacteria, to have COVID, than if you have not had diabetes, right? Again, this is comparing them to no diabetes, right? So 2.9 times more likely if you've had diabetes for less than 10 years, and 5.57 times more likely if you've had diabetes for greater or equal to 10 years. So if you have diabetes, you're more likely to have the bacteria. And then the longer you've had diabetes, the more likely you are, right? So you can see that increasing odds ratio. So less than 10 years compared to no diabetes, 2.9 times as likely. And then more than 10 years compared to no diabetes, 5.57 times as likely. Now, if you do it for the types of diabetes, so which type of diabetes is really sort of spiking those bacteria rates, spiking those COVID infections? Well, type 1 diabetes, again, compared to nothing. So type 1 diabetes, 17 times as likely as no diabetes to have it, right? This is where you can't even regulate your insulin at all. Okay, now if you could regulate your insulin, but you can't sort of regulate it effectively, so you could produce insulin, but you can't regulate it. That's type 2 diabetes, where you have the key to control your blood sugar, but the key's broken. That odds ratio is lower, right? So bigger odds ratio is more effect, more likely. So odds ratio 17 times as likely. Odds ratio 3 times as likely. Again, the p-values are really low. P-value 0.000 means it's statistically significant. The bigger the difference, the more statistically significant it is. Let's review the tables here. So people without bacteria who did not have diabetes, 23,884. People with bacteria who had diabetes, right, 713. So if it's equal to 1, that's basically yes. So bacteria equals 1, yes, they have the bacteria. Bacteria equals 0, no, they do not have the bacteria. So no bacteria, no diabetes, 23,884 people. You had diabetes for less than 10 years and you have the bacteria, 443 people. Diabetes for more than 10 years, no bacteria, 601 people. Diabetes more than 10 years, and yes, diabetes. So you can see the different numbers there, right? Again, the table's showing how many people are in these groups. So no diabetes, no bacteria, 23,884. Type 1 diabetes, yes, bacteria, 40 people. The differences in bacteria between the different types of diabetes is statistically significant, p-value 0.000. Odds ratio 3.5, diabetics are 3.5 times as likely to have bacteria compared to people without diabetes. Odds ratio 2.9, so people with diabetes for less than 10 years are 2.9 times more likely to have the bacteria as compared to people with no diabetes. Odds ratio 5.5, so people with diabetes for more than 10 years, 5.57 times as likely to have bacteria as compared to people without diabetes. So again, you're comparing people with these different durations of diabetes, different types of diabetes compared to no diabetes. So type 1 diabetes, 17 times as likely to have the bacteria, and type 2 diabetes, 3.386 times as likely. Right, so you can see those odds ratios there. You can see the do file, and now when you run the graph, you can see the graph and data there. So who has higher rates of bacteria? People with diabetes for a longer time period.